Hello, my name is Nick Huntington Klein. This is going to be the first in a series of videos about causality, including this first video, which is going to be about sort of what is causality, what are we trying to do when we're trying to talk about causality, and how can we start to get at causal effects. So first of all, let's define what causality is. So we're going to say that some treatment variable X is going to cause some outcome variable Y if we could move in, we could sort of reach in with our hands and change what the value of X was, we would see something about Y change as a result. Right? So that's not the same thing as saying that those two variables are correlated. Specifically, we're talking about if we could make X change, then something about Y would change as a result. Right? Let's say that we had some sort of medical treatment X. Let's say we're talking about sending you to the doctor's office. Does the doctor's office make you healthier? Well, we could look at some data. We could say, okay, we gathered a whole bunch of data on whether or not people went to the doctor's office and how healthy they were. And we would probably observe that those two things are going to be correlated. But it could be correlated for a number of reasons. It could just be that people who are more concerned about their health in the first place are more likely to go to the doctor. It could be that sicker people tend to be more likely to go to the doctor. We might actually find that on average, people who go to the doctor are less healthy. But does that mean that going to the doctor makes you less healthy? Not really. Maybe the doctor's office makes you more healthy. However, less healthy people are likely to go to the doctor's office. And so in the data we observe, we notice that people who go to the doctor are less healthy. Causality is saying, well, what if we could reach in and change whether you go to the doctor's office? So ignoring the fact that some people are more or less likely to go, we're going to take everybody and we're going to say, hey, everybody, we're going to reach in, we're going to force you to go to the doctor's office and see what happens to your health as a result. That's causality. Now, of course, there are a couple of instances in which you can see two variables that might be correlated with each other, and yet the causal effect might not be what we expect. So the doctor's office example that I just gave you is a good example. You might observe that people who go to the doctor are less healthy, even if the doctor is making them healthier. You might see that two variables are correlated with each other, even if neither of them has any causal effect on the other. For example, you might observe that people tend to be more likely to buy ice cream on the days where they wear shorts, right? But it's not the shorts that made them buy the ice cream, and it's not the ice cream that made them wear the shorts. It's probably just the fact that it's a hot day that causes both of those things to happen. So if you can think about with our definition of causality, if you reached in and you forced people to wear shorts, it wouldn't affect whether or not they buy ice cream. And if you reached in and you forced people to buy ice cream, it wouldn't affect whether or not they wore shorts, right? Because they're doing both of those things for some other reason. So that's what our idea of causality is. If we could reach in and change the treatment variable, it would change the outcome as a result. Now, that might not always work, right? So for it, all that needs to happen is it changes the probability of it. So, for example, you might, even if going to the doctor makes you healthier, just because we make you go to the doctor, that might work for some people and not work for other people. It might not always work. It might sometimes work. It might work better for some people than for other people. We might observe sick people who never go to the doctor and sick people who do go to the doctor. All that's important is that causal effect, that going to the doctor, changes the probability that you get sick. It doesn't necessarily always have to work or not. So that brings us to a question. Well, if we have this idea of causal effects and all we can really do is see the data that we have, we can't really go inside your blood cells and figure out, okay, did going to the doctor make you specifically sick? All we have is the data. All we can see are the outcomes. So how can we figure out, with the data that we have, whether or not going to the doctor makes you sick? Well, one common way that people do this is they run an experiment, right? They might run some sort of randomized experiment where they take a whole bunch of people and they randomly say, hey, you half of the people, you're going to go to the doctor, and you half of the people, you're not. That's us explicitly reaching in and changing the treatment variable, right? We have control over the treatment, which allows us to see what's going to happen in the outcome. And that's a good way to try to get at causal effects because it gets to the definition of causality, the fact that we are reaching in and we're changing the thing that we want to see the effect of, which is what causality is. However, you can't do that all the time, right? There are a lot of things for which you just can't really run an experiment. Maybe it's unethical to run an experiment. For example, you wouldn't want to randomly assign some people to start smoking just so you could figure out what the effect of smoking is. It might also just be infeasible. You can't really run an experiment, for example, on the value of democracy, because you can't force an entire country to, to either be democratic or not democratic based on what the researcher tells them to do. That's just never going to happen. So we need to have some way of trying to understand causality without being able to run an experiment. And that's what a lot of these videos are going to be about. And so when we're trying to get at that, the real key that we're trying to understand is, what is the counterfactual? That is, what would have happened if somebody did or did not get the treatment, which is, counter to the fact of what actually happened. So let's go back to the doctor's visit example. So let's say that we have a bunch of people, and some of them went to the doctor and some of them didn't. Okay, and we observe whether or not they're healthy or sick. So we can't just, like we mentioned before, just compare the outcomes for those two groups of people for whether they went to the doctor or not, because they might have gone to the doctor because they were sick in the first place. And so we're going to get a bad result. What we really want to do is try to say, okay, I observe you. Let's say that your name is Joe. And Joe, I observe that you went to the doctor and you got sick. Okay? So what we want to figure out is, what would have happened to Joe if Joe specifically had not gone to the doctor? That's the counterfactual. What if? What would have happened if Joe didn't go to the doctor? Now, we have a problem here. This is called the fundamental problem of causal inference, that we can't possibly know that. We only exist in one universe. All we can do is observe that Joe did go to the doctor, and there's no data that we can possibly collect to see what would have happened if Joe didn't. And so all of these tools, all of this causal inference stuff that we're going to try to get at is going to all be about trying to guess what would have happened to Joe if Joe had not gone to the doctor. Now, we have a lot of tools for trying to get at that. Maybe we did run some sort of experiment, and so on average, we can see what happens to people who don't go to the doctor when we force them not to go. Maybe we have some sort of way of finding somebody who looks a lot like Joe. So we don't know what would have happened to Joe if Joe hadn't gone to the doctor, but we can say, okay, well, Joe is a guy. Joe is 32 years old. Joe has blonde hair and blue eyes and, has a history of emphysema. Who knows? Well, we can find somebody else who is 32 years old, is a guy with blonde hair and blue eyes and a history of emphysema who didn't go to the doctor. And then we can see what happened to that person. Right? Sort of the best possible comparison. Now, you can think of some reasons why that might not work, right? Maybe there's some reasons other than those 5 things I just mentioned that could be important to Joe's health. But that's what we're trying to do. We're trying to find basically a way of getting a comparison that's so good that we have a really good idea of what would have happened to Joe. And if we can say, yeah, Joe would have been sick whether or not he went to the doctor, because we know what happened if Joe did go to the doctor, he got sick. And we have a really good guess as to what the counterfactual is if Joe didn't go to the doctor. And so the doctor, for Joe, didn't have an effect. Maybe we have somebody else who went to the doctor and didn't get sick. And we find that their counterfactual, if they had not gone to the doctor, is that they would have gotten sick. So in that case, we would say for that person, the doctor prevented them from getting sick. And so when we're trying to do causality, that's all that we're trying to do. We're trying to figure out what is the effect of this treatment on this outcome. Is, in other words, what would have happened if we reached in and changed the value of that treatment. And we can get at that answer. We can figure out what the answer to that is, either by running an experiment or by trying to figure out what would have happened if the counterfactual had occurred instead, which we have a number of tools to try to do. And that's something that we're going to get at in these series of videos. I hope you'll stick around for those. Thank you.